Hi everyone, we're going to look at exponents today. So first off, what is an exponent? An exponent tells me how many repeated factors we're going to multiply together. So we're going to start off with 4 to the third power. The base number is the big number. So the base here is 4. And then the 3 is the exponent. It tells us how many factors of the base we multiply together. Multiply. Okay, so the base is 4 and the exponent is 3, so we're going to multiply 3 4s together. 4 times 4 times 4. 4 times 4 is 16, times 4 gives us 64. Okay. So what is the base? The base is x. Okay. So how many factors of x am I multiplying together? I am multiplying 2 factors of x together. Okay. So that's expanding. Since I don't know the value of x, I got to stop there. Okay, this one. This is x to the third y squared. So the power only belongs to the number right next to it. So in this case, we can look at these as 2 sets of factors. So x to the third, there's 3 x's being multiplied together. And then how many y's are being multiplied together? That's right, 2. Okay, so that's our expanded form using exponents. So exponents is a way to shorten up an expression if it's written out like this. Okay. So what about if my power is a 0 or if my power is negative? In order to do this, we're going to look at the equation y is equal to 2 to the x. So I'm going to start with y is equal to 2 to the x. We're going to replace the x with 1. Okay, so 2 to the first power is 2. We're going to do this again. 2 to the second, that would be 2 times 2, which is 4. Y is equal to 2 to the third, which is 2 times 2 times 2, which is 8. So the pattern here is, how do I get from 2 to 4? Well, I'm multiplying by 2. 4 to 8, I'm multiplying by 2. So if I reverse the pattern, instead of multiply, the inverse would be divide. So I'm going to divide by 2. So 2 divided by 2 would give me 1. So y is equal to 2 to the 0 is 1, because that's what fits in the pattern there. So I'm going to take this 1, again, we're going to divide it by 2. So 1 over 2. So y is equal to 2 to the negative 1 is actually 1 over 2. Take this 1/2 and divide it by 2. What did you get? I got 1/4. 1/2 split into 2 would give me 1/4. So y is equal to 2 to the negative 2 would give me 1/4. So what is y is equal to 2 to the 0 power? That was equal to 1. So check it out. We got some properties of exponents. Any base raised to the 0 power equals 1. So x to the 0 power would equal 1. This one's a little tricky. Remember that the 0 is only being raised, the y is only being raised to the 0 power, so it could look more like this. Okay, so the negative 5 I'm going to bring down. What is y to the 0 power? That's 1. So this is going to give me negative 5. But the part where we evaluate the y to the 0, that is still 1. Okay, so now let's look at negative exponents. Y equals 2 to the negative 1 is going to equal 1/2. Y to the negative 2 is going to equal 1/4. So what happens when we have a negative exponent? Do the outputs become negative? No, they actually become fractions. Okay, and then also fractions will become whole numbers if you started out with large numbers. Okay, so negative exponents, what we're going to do is, let's do this example. It's the inverse. The negative means an inverse. So instead of multiplying by y 3 times, what I want to do is create a fraction sign. Any number that has an exponent that is negative is not happy where it is. It's not happy in the numerator, so we want to divide it instead in the denominator. So we're going to move the y to the bottom, and the exponent moved location, so it is happy now. So we make the exponent positive. When there's nothing left on top, there's actually a 1 left on top. Okay. Next up, wow, that one took a long time to get there. Okay, so this one, I can see there is really a power of 1 on the 2. And then, I don't know what happened to my screen. No devices connected. Let's try this again. See if we'll come back. Okay. And then the bottom, x to the negative 4, well, the top 2 to the first power has a positive exponent, so it stays on top, 2 to the first power. The x's are not happy, so they're going to come up to the numerator, x to the 4th power. So instead of dividing by x to the 4th, we need to multiply, which is why it moves places. X to the 4th. Okay, so the negative exponent rule is any exponent, any base with a negative exponent can become a positive if you move it to from the numerator to denominator, or if it started in the denominator, you move it to the numerator. Okay, so move it and then make the exponent positive. All right, so we're going to use some of those rules below. We have more exponent rules. Product property. All right, so check it. We're going to expand these. This is the long way to do this, and then I'll show you a shortcut. Okay, so this is really the 3 is being given to the first x, so I have 3 x's being multiplied together. The second parentheses, x to the 4th, how many x's are multiplied together? I have 4. So 1, 2, 3, 4. In total, how many x's are we multiplying together? I have x to the 1, 2, 3, 4, 5, 6, 7. Okay, so what do you notice about what I did with the 2 exponents here? That's right, I added them. I did x to the 3rd plus 4 gives me x to the 7th. So when we multiply bases with exponents, we add the exponents to combine. Okay, so let's go ahead and look at this second one. I have negative 5 times y to the fourth and 2 times y squared. I'm going to rewrite this to be negative 5 times 2, and then put my y's together. So y to the fourth times y squared. Okay, so if there's whole numbers, you just multiply like normal. So negative 5 times 2 is negative 10. And then let's expand the y's. So y times y times y times y. And then the second set of y's here is y times y. So I get negative 10 y to the 1, 2, 3, 4, 5, 6. Okay, the short way. I'm going to take my negative 5 times 2 times y to the fourth times y squared. So negative 5 times 2 is negative 10. Y to the fourth times y squared. I'm going to take y to the fourth. Since the bases are being multiplied, I add the exponents. So I get negative 10 times y to the 4 plus 2 is 6. You can do this either way. Okay, you can expand, so you can expand, or add the exponents. Okay. All right. Next, quotient property. Quotient property, we're going to expand this first. So this is y times y times y times y times y 5 times. And in the numerator, we have, the denominator, excuse me, y times y times y times y. How many times? That's right, 9 times. That's 6, 7, 8, 9. Okay, so anything divided by itself is going to make a 1. So y divided by y makes a 1. Y divided by y makes a 1. Y divided by y, a 1. Y divided by y, and a 1. I'm left with nothing on top, but actually an invisible 1. And then how many y's am I left over on the bottom? I have 1 over y to the fourth power. So if you look at the exponents, what did we do with them? We subtracted them. So the short way is to do this. Okay, so I do y to the fifth over y to the ninth. If the bases are being divided, I'm going to subtract the exponents. So I'm going to do y to the fifth minus 9. So I bring the 9 up. Okay, so I get y to the negative 4. And we always leave our answer with positive exponents. So I'm going to write this as, if I want the exponent to be positive, I'm going to move it down to the other level. So y to the fourth. And then if there's nothing on top, we leave a 1. Same deal. Okay. All right, next one. I have 10 over 6 times x squared times y to the fifth over y cubed. Okay, so I kind of separate them out so I can see what stuff is going to cancel. To start, the whole numbers, we go ahead and we just divide those. What divides out of 10 and 6? I think a 2, right? So I get 5. 10 divided by 2 is 5. 6 divided by 2 is 3. All right, we took care of that part. The x squared has nothing to divide with it, so I just leave that. And then the y's, let's see. So the bases are being divided, so I can either expand it out, and then 1, 1, 1, and I'm left over with y squared. The other way I can do this is look at y to the fifth, move the 3 up, so to the minus 3 gives me y squared. Okay, so when the bases are being being divided, subtract the exponents. Here's an example. Y to the third over y to the first, we do y cubed minus 1 gives me y squared. Let's do an example for the product property too. Here's an example. So x squared times x to the fifth gives us x squared plus 5 equals x to the 7. Okay. Last property, power to a power property. So this time, if you notice, the power of 4 doesn't have its own base. It actually does. Its base is everything inside the parentheses. So what I have here is 4 copies of v squared. So I'm going to expand it. V squared times v squared times v squared times v squared. And then I'm going to expand each one of these. This is v times 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 v, which gives me v to the 8th. That's a lot of work. What did you notice about these, the 2 and the 4, to give me 8? That's right. What I can do in the shortcut is v squared to the 4th power. So if the second power does not have its own base, okay, what we're going to do is just multiply these exponents. We get v to the 8th power, v to the 2 times 4. I'll write that out. V to the 2 times 4. Okay, so let's go ahead and do this next one. So what is being raised to the second power, because the power is on the outside? Everything inside. So the 7 really has a first power, and then the v cubed is also being raised to the second power. So what I have here is 7 squared times v to the third to the second power. Okay, so 7 squared is 49. And then how do I tackle this v cubed to the second power? Well, I go ahead and just multiply the exponents. So that would give me v to the 6th power. And we done's. Okay, so power to a power. So when a base is being raised to 2 powers, we multiply the exponents. Okay, so an example is v to the second to the third would give me v to the 2 times 3, which is v to the 6. Okay, I'm going to do a second video with a lot more examples, and you're going to try them and practice, and try and practice, okay? These get tricky.